Okay, so lesson 25, word problems with logarithmic and exponential equations. So some of you guys might have seen some of these if you've taken like chemistry, mostly chemistry, physics 30. Yeah, like you'll get some exponential equations that show up, and you'll get some log equations, right? Like you guys have probably, if you were in chemistry, have seen, you know, they've written like this maybe or similar to this before, right? So same thing. You've probably done some of these questions even. We're just gonna do it again, maybe a bit more understanding of what logs are this time. So all right, as we go through these, there's different scales that are either like logarithmic scales or exponential scales. And we're just gonna kind of try to hit every one of them because any one of them are like fair game for diploma or any of the questions, right? So there's gonna be like the pH scale, the decibel scale, earthquakes, or the Richter scale. So we'll just try to do as many as we can here. So, all right, pH is a measure of the concentration of hydrogen ions, and that'll be written like this in this situation. Don't be intimidated by that. All this is saying is that like positive, like, so this is a hydrogen ion, right? So H plus. And then the AQ, for you chemistry people, what does that mean? Aqueous. Yeah, aqueous solution, right? So, yeah, we don't need to worry about that in math, right? So the greater the concentration of hydrogen ions, the lower the pH. So a pH between 0 and 7 refers to an acid. A pH of 7 is neutral. And a pH between 7 and 14 refers to a basic solution. So it can be written out like so. Okay, now just be careful what you're looking at here, right? So there's two different things. You've got your pH, and then you've got your hydrogen concentration, or concentration of hydrogen ions, right? So just be careful what we're actually looking for in the question. So it says, in spring, the pH of water in a mountain stream is 4.2, right? So that's this, right? The pH is that. It's 90.5 times more acidic than in the fall. So the more acidic than in the fall, what that's referring to there is there's 90.5 times more hydrogen ions. And maybe this question wasn't worded the best because, you know, more acidic, it might not be as implied as you think there. You might be thinking that means pH. But more acidic, you're thinking, okay, it has that many times more hydrogen ions in that solution, right? So now it says determine the pH of the water in the fall. Okay, so let's write out a little expression here to begin with. So we'll say, all right, the hydrogen, so H plus, in the, and I'll write SP for spring. This is just a number, right? This is the number of hydrogen ions in the spring, is equal to, and then you could say it's the number, the hydrogen ions in the fall. And then times 90.5. Do you guys kind of see that? That the spring would be whatever the fall was times 90.5, right? Is 90.5 times more acidic. That's kind of our starting point there. Now, what we have to do here, like if I want to have my hydrogen ions is equal to my hydrogen ions, let's look back at our equation here, right? We had pH. Actually, you know what, too? I'm going to do, I'll write the whole thing again. pH, capital H, is equal to negative log, I'm just going to write it as H plus, without the aqueous. So what I'd like to do, if this little equation I made myself over here deals with hydrogen ions, right? I'm going to rearrange this so that I'm dealing with what H is equal to, right? So this is that last skill that we learned in the last lesson, right? I need to solve for H plus in this case, right? So what I'm going to do is I'm going to get this negative out of there first. So I'm going to divide both sides by -1, or just swap the negative over to this side. And that's equal to log H plus. How do I unlog this thing? I need an expression where it's like H is equal to something. maybe this will help as a little hint. When we write a log with nothing underneath it, remember that that's actually log base 10. Yep.
So then the 10 to the power of negative pH in this case gives us h plus?
Yeah, exactly, right? So this is just rewriting this in exponential form. 10 to the power of negative pH is equal to h. Or you could do that same little trick we did last time, right? We could have just rose them both to the power of 10, right? So it'd be the same thing, but either way, in the end, we get 10 to the power of negative pH is equal to h plus.
It all makes sense now.
From chemistry? Yeah.
They kind of did that, but they didn't explain why.
Yeah.
Yeah.
I think that's partly why I didn't like chemistry.
So now that we have this figured out, right, we can actually put numbers in for this. So we are looking for fall, right? So here, I'll just put the numbers in as we know them here. This would really be 10 to the power of negative, well, it's 4.2 for my pH in the spring, right? So 10 to the negative 4.2 is equal to, and then I'm looking for this one. I'll write the 90.5 out front, so that'd be 90.5 times H plus for the fall. Okay, so you guys probably see where we're going with this. We just have to divide by 90.5 on both sides. So we end up getting H plus for the fall is equal to, it ends up being 6.97 times 10 to the negative 7. Okay. So now, does that make much sense for my pH though? What did I just find there?
Concentration.
Yeah, that was my hydrogen concentration, right? So my last step here is going to be just to put it back into the original equation. So we can say, okay, then pH is equal to negative log of that 6.97 times 10 to the negative 7. So we end up with a pH of 6.2. All right, let's get shaken. All right. All right, so the Richter scale is measuring earthquakes, right? When you think of the Richter scale, that's measuring the magnitude of an earthquake. So it's a logarithmic scale used to describe the relative strengths of earthquakes. The formula for determining the magnitude of earthquakes is this, right? So the magnitude, M, is equal to I, so the intensity of the earthquake, over, and then this is called the baseline intensity or the minimum intensity of an earthquake. Okay, so this is just kind of what we're measuring at. It's like our baseline. If you guys taken physics, right, it's like you can measure potential energy. It all depends on where you measure from. Right? It's the same kind of type of a concept here, right? Where if we're measuring how much something's shaking, we always have to compare it to something, or else it doesn't really make any sense. Yeah. So yeah, same idea. Okay, so the example says the strongest earthquake in Alberta was 4.4. How much stronger is the strongest earthquake in the world if it measured 9.5 on the Richter scale? Okay, so the way we can do this is, well, again, just figuring out what we're looking at here, right? So the strongest earth was 4.4. This is a magnitude. Okay, now, so in Alberta, what we can say is, well, first off, you know what I'm going to do? Let's rewrite this thing a little different. Can we write this as an exponent? Yep.
This is 10 to the power of m gives us
Yeah, I over I-O, right? So we can rewrite it like that. Okay. So when it says how much stronger is the strongest earthquake, what it's actually looking for there is the intensity, right? When it says stronger, And that's kind of the hard part of these questions, is figure out what's asking for. Because the magnitude is just the number that we give it, right, based on the Richter scale. But the intensity is really like how strong it's actually shaking, right? So when it says how much stronger, it's saying like how many times bigger is the one intensity than the other intensity, right? So here, so in Alberta, I'm going to make a little equation for intensity. So I'll say in Alberta, we'll say it is 10 to the power of the magnitude, right? So to the power of 4.4 is equal to I over IO. And we should write this as like I subscript A or something, so remember it's like Alberta. Okay, so my little equation that I'm going to have for Alberta, if I rearrange this, would just be the intensity for Alberta is going to be 10 to the power of 4.4 times IO. And we don't know what IO is, but you guys will see what happens here in a second. Okay, so now the world. So that would be same process, right? That would be 10 to the power of 9.5 this time is equal to I over IO. So our little equation would be I, well, IW maybe for I world, is equal to 10 to the power of 9.5 times IO. Okay, now this says how much stronger. And again, I think this could have been worded a little bit better. This probably should have said like how many times stronger is it? Is typically the way these questions are worded. So if we were figuring out how many times bigger 10 was than 4, well, what you would do is you just go 10 divided by 4, right? To figure out how many times bigger it is. We're going to do the same thing with these numbers. So it would be how many times bigger is the world one? So that's going to be IW divided by IA. That's going to tell us how many times bigger it is. And then we can just write that as, okay, well, intensity for the world was 10 to the power of 9.5 times IO over 10 to the power of 4.4 times IO. You guys kind of seeing why the baseline intensity isn't really going to matter in the end here? Yeah.
We're just going to cancel them?
Yeah, we're just going to cancel them, right? Which kind of makes sense if that was the same for both, and they would just end up canceling out of the equation. So, okay, so those cancel. So in the end, that's just going to be equal to, and you could put this in your calculator, but we have laws for this, right? What else could we do?
10 to the power of 5.1.
Yeah, right. So that's going to be 10 to the power of 5.1. How'd you know that? Exponent laws. We just subtracted there, right? Same bases, dividing, so we subtract our exponents. So 5.1 times as intense. So yeah, what is that if you're, well, that'd be close to, just so you're aware, right? It's bigger, like a little bigger than that, right? Or quite a bit bigger than that, but it'd be that many times as intense, right? So the Richter scale and a lot of these logarithmic and exponential scales can be deceiving because you're like, oh, okay, well, 4.4 and 9.5. Somebody might think, okay, well, that's probably about twice as bad, like just roughly. No, it's 100,000 times as intense.
So we could have just done 9 point.
We didn't really do any math there. I wanted to, we didn't do much. It's setting them up, right?
We pretended to do that.
Yeah. All right. Moving on to the next one. So, can you guys keep the volume down? All right. So, intensity of sound has the same logarithmic quality, right? So, we measure sound in a unit called decibels, so dB, and the formula is similar to the other one, right? The only difference is that it's 10 times log and then I over IO for the loudness of something. So L is the loudness, I again is the intensity, and IO is the minimum sound of that the human ear can detect. Now, if you think about it, this isn't actually much different than the Richter scale, because remember what sound is, right? Sound really is waves, right? Richter scale really is waves. So that's one of the reasons why they're going to be so similar here, right? All right, so in this example, it says portable music players can produce sounds up to 125 decibels. Any sound above or about 90 decibels can cause hearing loss if exposure is prolonged. To be safe, experts suggest that the volume does not exceed 60% of the maximum the player can produce. Assuming your player is at this maximum, how many times more intense is this than the recommended setting? Okay, so what we have to do, we've got to figure out how intense this is, how intense this is, right? 60% of it, and then just figure out how many times as intense the one is than the other. So it's really similar to the other problem, right? The only thing we have to add to this one, we got to figure out what 60% of 125 is to figure out that one, right? So our recommended is going to be equal to 0.6 times the max, right? So that's going to be equal to 0.6, and our player goes up to 125 decibels. So that's going to be 125 dB is equal to 75 dB. Okay. Yep.
And that works because
the volume here is referring to the loudness.
Okay.
Yeah, it's what. Yeah, good call. That's what it's referring to. It's not saying the intensity is 60% of the maximum. It's going to be that the volume will be your loudness in that case. Yeah.
Why is the word?
So we're actually just going to do the same thing here. So the recommended. So the recommended is going to be I over IO is equal to, oh, sorry, you know what? I forgot to explain how to change this one. So our problem is, we want to actually get an equation for I, like we did in the last one, because it's asking for how many times as intense is it. So I need I on its own. So let's do that first. So if we wrote down L is equal to 10 times log, and then I over IO. And I need I on its own there, right? So first thing I'm going to do, I'm just going to get that 10 out of there. So we're going to divide both sides by 10. So then we've got L over 10 is equal to log I over IO. All right, now what? Kind of way, change that into exponential form. Yeah, either way, if you like, we can do our other trick there, right? 10 to the power of and 10 to the power of. And then we'd end up with 10 to the power of L over 10 is equal to, and then 10 log base 10 is just 1, right? So that's I over IO. Yep.
Can I go fill my water?
Yeah, sure. Okay, and then I'm just going to bring the IO up. So then we've got 10 to the power of L over 10 times IO is equal to I. Okay, so now we're just going to do that for the recommended and for the max again. So we're going to have, for the recommended, we've got I, R I'll call it, is equal to 10 to the power of 75 over 10 times IO. 75 was just our from above, right? Okay, I can write that a little better though. Let's just write that as a decimal. We'd say IR is equal to 10 to the power of 75 over 10. That's just 7.5, right? Times IO. Okay. Now the max. So same thing. So we'll say I max is equal to, and then the
10 to the 12.9 then?
yeah. Are you okay if I just go 12.5? Because that'd really be 125 over 10, but 12.5 times IO. Okay, now the question's saying how many times more intense is one than the other, right? So this is just the same thing we were doing before. Yeah, so we're going to say the max, the intensity of the max intensity over the recommended intensity is equal to 10 to the power of 12.5 times IO over 10 to the power of 7.5 times IO. So IO's cancel, and we end up with 10 to the 5. 10 to the 5 times more intense.